Today we're going to be jumping into our new unit, Chapter 9, which is all about statistical measures. And today we're just going to do a quick introduction to what statistics is. So first off, our definition of statistics. So our definition right here says that statistics is the science of collecting, organizing, analyzing, and interpreting data. A statistical question is one for which you do not expect to get a single answer. Instead, we expect a variety of answers, and you are interested in the distribution of those answers. So, for instance, in a statistical question, you wouldn't just be expecting, one or two answers, a yes or no, perhaps, or if you ask somebody what the weather outside is, that's not going to be a varied answer. Versus a statistical question, you're going to be expecting a variety of different answers from people. So using statistics, and when we ask statistical questions, we can use dot plots and number lines to show the number of times each value in a data set occurs. A dot plot shows us the spread and the distribution of the data that we collect. So let's just jump into our example problem right here. So example 1 says you conduct a science experiment on house mice. Your teacher asks you, what is the weight of a mouse? So your experiment, you have a whole bunch of different types of house mice. You don't just have one, you have a few. And so when your teacher asks you, what is the weight of a mouse, is this a statistical question? And it is. And the reason it is that because we can anticipate that the weight of the mice will vary. So we're going to say yes. Because we can anticipate that the weight of the mouse will vary. That the weight of the mice will vary. Now, the reason we can anticipate this is because we can say that not every single mouse that we weigh is going to be exactly the same. We could have one mice weigh 20 pounds and we could have another that would weigh 17. So those weights are going to vary. They're not always going to be exactly the same. So that is why it is a statistical question. Because if you went around and asked every single student in the class, well, what does your mice weigh? We wouldn't be able to give a firm one answer to that question because the weights will be different, even if they're different by just a little bit. So part B says you weigh some of the mice and record the weights in grams. And so I just picked some weights and I put them right here in this little table, which you can draw on your paper if you want. It's a really bad arrow that I'm drawing here. So it asks us to display this in a dot plot. So we have all this data over here to the right, and it wants us to display it in a dot plot and then identify any clusters, peaks, or gaps that we see. So to draw a dot plot, we are first going to draw a number line. So I'm going to go ahead and draw a number line right here. And this number line has to include the least value and the greatest value in this data set. So if we can look through this data and see what's our least value and what is our greatest value. So our least looks like it is 18 right here. And then our greatest value, if we look through this data, looks like it would be this 28. So I'm going to start over here on the left and put 18. And then I'm going to go all the way up to 28. Okay, the second part of drawing my dot plot is to draw a dot for every single number that is represented in this box right here. So I'm going to start off with 20, so there is 120, and every single time I draw, I'm going to cross it off just so I know I've used it. So I'm going to put one dot on 20 right here. Go over to 19. 18, 28, another 20. And when I go 20, I'm going to put it on top of each other. 21, another 19, which I'm going to stack them right on top of each other. Another 20, 23, 22, another 21, 27, another 20, 18, 21, 20, 21, 19, 27, and last but not least, another 20. So this is what a dot plot looks like. We have our range going all the way from 18 to 28. That's our range of numbers that are represented. And then every single number that's actually represented in this table over here, I put a dot on the dot plot, and that is why it is actually called a dot plot. So now that we have displayed our data, it asks us to identify clusters, peaks, and gaps. So the first thing that I think is the easiest to identify is our gaps. So one big gap that I see is right here from 23 to 27. So this is a gap right here in the data. This means that there's nothing represented, no numbers represented all the way throughout here. So that's a gap in between the data that we displayed. A peak, I always like to think if you ever see mountains, if you see a big peak, it's the tallest mountain out there. So our peak right here is this 20. It's the tallest amount of dots that we have. That's our little peak. And then last but not least, our cluster. So cluster is where it's kind of the opposite of a gap. It's where we see a lot of our dots in the data display. So where are they all kind of clustered around or grouped around? And that is in this area between 18 and 22. So I'm going to put a little circle right here. So this is our cluster. And so that's it. That is how we display our data, our statistical question, into a dot plot and identify any clusters, peaks, and gaps in the data. And this is just a great way for us to visually see any differences or similarities in our question, which was how much the mice weigh. So this is an easy way to see, what is our cluster? Where do all of the mice kind of compare and weight? And then where are outliers, or where is this gap, this 27, this 28? And we'll talk about outliers a little bit in our next video. Let's go to our last question. Use the distribution of the data to answer the question. And so it says, what is our original question? If you remember up here, it says, what is the weight of the mouse? So it's asking us to use this distribution to see, just looking at this data plot, if we had to make an educated guess, what would we say most mice weigh around? And looking at this, looking at our peak, we can say that most mice weigh about 20 grams. So to answer the question, we just went over to our peak to see, well, what do most of the mice in our experiment weigh? And it was 20. So we can make that educated guess and say, well, most of the mice that we weigh are going to be about 20 pounds. All right, let's move on to example 2. So example 2 has this thermometer, and it says that you recorded the high temperature every day while you were at summer camp in August. And then we create a vertical dot plot. So if you can see on the left-hand side here, we have our degrees. So we have all the way down to 80 and then all the way up to 87. So these were the highest temperatures at camp. And these dots are representing every single day that we were at camp. So for 4 days, we had a high of 87. And then for 3 days, we had a low of 80. So each of these dots represent a day. So B, it asks, how can you collect these data? What are the units? Oh, I kind of have these questions out of order. So B came first, which is fine. We'll just answer that. So how can you collect these data? This is kind of an easy question because we can see the thermometer right there. And so the way that we would collect this would be by using the thermometer. So we can say, we can collect this data by using a thermometer. I don't think I'm spelling this right. Thermometer. I think I need to. See, THERMOMETER. Sorry, guys. Math teacher here. Okay, so we can collect this data by using a thermometer. So basically, if someone came up to you and said, how would you collect your data, which is how would you tell us or how would you collect the temperatures while you're at camp, the easiest way to do that would be through a thermometer. So that is what that question is asking us. So really what our first question was A, which is how many weeks were we at summer camp? And so the way to answer this question is, first of all, how many days are represented in our thermometer up here? So let's count them out. We have 3 right here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5, and then 3. So all together here, we have 28 data values represented, which means that we collected data for 28 days while we were at camp. So the question is asking us how many weeks were we at summer camp, and hopefully by now we know that there are 7 days in a week. Right? 7 days in a week. And if we had 28 days, we're just going to go ahead and divide our 28 days. What's telling me right? Let's see. There we go. We're going to divide our 28 days by 7 to get 4 weeks. So we were at summer camp for 4 weeks because we were there for 28 days, which is equivalent to saying 4 weeks. All right, our last question, it says, write a statistical question that you can answer by using the dot plot, and then answer that question. So let's just think of one. So if I was looking at this dot plot, one possible question I could ask would be, what was the daily high temperature in August? So our entire experiment was collecting the temperatures throughout our entire month of August. So a statistical question I could ask is, what is the daily high temperature in August? Okay. So let's go back up and answer our own question. So if we go back up and see what was our daily high. So the high temperatures are really spread out, with about half of the temperatures around 81 and then half of them around 86 degrees. So we can say that our 2 highest days, if we're looking at this data right here, our 2 highest days we had 81 degrees, and then our other highest day we had 86 degrees Fahrenheit.